Hi class, Dr. Sylvie here. In this short video, I want to discuss how we can predict solubility for molecules that have both polar and nonpolar groups. So to illustrate how we might think about this, I'm going to talk about solubilities of alcohols. And small alcohols like methanol are soluble in water. Methanol has this kind of one nonpolar group, or just one carbon atom, and then all alcohols have this hydroxyl group, this OH group, that can act both as a hydrogen bond donor and a hydrogen bond acceptor with water. On this side, I'm showing the alcohol's lone pair on oxygen to be the hydrogen bond acceptor, and that hydrogen bond is drawn in here. In this picture here on the right, I'm showing our alcohol group is the hydrogen bond donor and donating its hydrogen atom to the lone pair on oxygen in the water molecule. So alcohols act as both hydrogen bond donors and hydrogen bond acceptors with water. So what happens as we go from, say, one carbon on an alcohol molecule to a lot of carbons on an alcohol molecule? Here's some solubility data. And what I'm showing is the solubility in this column here. This is the solubility data. And here I'm giving the name, but this is showing alcohols going from here to here. We're going 1 to 5, and then here we jump up to 8 carbon atoms in that alcohol. And notice that all alcohols, because they all have this single OH group, have the capability of hydrogen bonding. But will they dissolve in water? And what we see from our data is that alcohols that have between 1 and 3 carbon atoms are infinitely soluble in water, or miscible. And what that means is that you can mix any amount of water with any amount of the alcohol, and you'll still have a homogeneous mixture or a solution. When we go to 1-butanol, the solubility drops. You can only dissolve 7.7 grams of the alcohol in 100 milliliters of water. And if you mix 1-butanol with water, you'd see 2 layers. It doesn't visibly look soluble at all. When you go up to 1-pentanol, that solubility drops to 2.2 grams of 1-pentanol per 100 milliliters. And when you jump up to 8 carbons, it's 0 solubility. So how can I use these observations of solubilities of alcohols to make general predictions for other molecules? And this is what I came up with, is that we can use a general predictor for solubility called total estimated polarity. And the total estimated polarity is going to be proportional to the number of oxygen plus nitrogen atoms, because they can hydrogen bond with water. Not only are they hydrogen bond acceptors with water, if they have an H atom, they're also hydrogen bond donors to water. So oxygen and nitrogen is going to be very important in this. Why not fluorine? Well, fluorine doesn't really occur in our food or in our bodies, so it's not really important here. And then we're going to divide by the number of carbons, because the number of carbons is going to dilute the polarity. As we saw, as that hydrocarbon chain length grew, the solubility went down. So here I just used that simple formula to calculate the total estimated polarity for those 3 infinitely soluble alcohols. And the one with the highest is the one with the least number of carbons, at methanol, with a TEP of 1. And then the one with the lowest was 1-propanol with a TEP of 0.33. So using this, I predict that molecules with a TEP of greater than or equal to 0.33 are likely to be water soluble. Well, what's the converse of that? The converse of this is, if something's not water soluble due to this growing chain, then it's going to be soluble in nonpolar solvents. And so I can also predict which molecules using TEP would be soluble in nonpolar solvents. And so molecules with a TEP of less than equal to 0.33 are likely hexane, fat, or oil soluble. Those are all nonpolar solvents. How might we extend this to predict the solubility of vitamins? Vitamins can be fat soluble or water soluble. So let's look at an example. So here I'm showing vitamin C, the structure and the chemical formula, and vitamin K3, the structure and the chemical formula. And I can calculate a TEP for both of these. So TEP, this just equals 1. It's 6 divided by 6, and that equals 1. And then the TEP here equals 0.18. That would be 2 divided by 11. And so this is greater than 0.33, and so we would predict it's water soluble, and it is water soluble, a water soluble vitamin. And then using this 0.18 is less than 0.33, and so we would predict that it's fat soluble, and it is fat soluble. I hope you found this video useful, and if you have any questions, please reach out to me via email. Thank you, and have a great day.